Hi everyone, welcome back to the Comptia Network Plus course, Bandwidth and Speed. Satisfying the need for speed involves moving large volumes of data, voice and video, loaded packets across vast distances to communicate. Companies' volume requirements have grown right along with their appetite for even bigger, faster connections. Speed, typically made possible with more bandwidth, is measured in bits per second or multiple of bits per second, such as kilobyte, thousands of bits per second, and there is no surprise here. The winner of the slowest wide connection prize is a much maligned dial-on-demand dial-up connections. Modern dial-up modems typically have a maximum theoretical transfer speed of 56 kilobytes per second, although most cases 40 kbs to 50 kbs is the norm. Factors such as phone noise as well as the quality of the modem itself play a large part in determining connection speeds. Modems are required to demodulate the signal, which means translating the analog signal our ears hear into a digital stream to transfer across a digital network. Some connections may be as slow as 20 kilobytes per second, which is in extremely noisy environments like hotel rooms where phone lines are shared with an abundant number of extensions. A megabyte, MB and gigabyte, GB usually refer to the amount of storage capacity available, whereas bandwidth and speed refer to units that measure how much data bits can be sent per second. In the networking world, speed is essentially the measurement of how fast the data flows hertz, and also refers to how fast data flows within memory systems. Sometimes the term bandwidth and speed are used interchangeably. T-series connection. The basic entry level in bandwidth or speed for leased lines that provide synchronous connections between sites is known as the T1. It serves up to 24 digital signal 0 DSO 64 kilobytes per second channels in the United States, Japan, South Korea. There's a slightly bigger, faster version with 32 DS0 channels that's available in Europe, and it's called the E1 or E1 carrier. T1 uses digital signal 1 DS1 bit patterns to transmit packets. DS1 has to do with the service to be sent over a T1 originally. 24 digitized voice channels. The terms T1 and DS1 have become synonymous and include a bunch of different services, from voice to data to clear channel pipes. The line speed is always consistent at 1.544 megabits per second, millions of bits per second, but the payload can vary greatly. For trivia lovers, T1 came from the carrier letter or part number assigned by AT&T to the technology. T-series connections are digital connections that you can lease from the telephone company. They use copper pairs like regular phone lines, or they can be brought in as part of a backbone, which is also called a trunk line. At this point, T-series connections use time division multiplexing or TDM to divide the bandwidth into channels or equal bit rate. T-series connection types are denoted by the letter T followed by a number. Each connection type differs in its speed and in the signal used to multiplex the channels. Table 16.1 lists some of the T-series connections and their maximum data rates. The most commonly used T-series lines are T1 and T3. T1 1.544 megabits per second, TC1 3.152 megabits per second, T2 6.312 megabytes per second, T3 44.736 megabits per second, T4 274 by 176 megabits per second. The T1 connection. So as T1 is a 1.544 megabits per second digital connection that's typically carried over two pairs of copper wires, this 1.544 megabits per second connection uses DS1 and aggregates 24 discrete 64 kilobytes per second channels that use DSO0, which refers to the time slots within a channel. Each channel can carry either voice or data. In the POTS world, T1 lines are used to convert and bundle analog phone conversations over great distances due to the better quality of a digital signal and the use of a great deal less wiring that would be needed if each pair carried only one code. This splitting into independent channels also allows a company to combine voice and data over one T1 connection, or use the T1 connection as if it were an unchannelized 1.544 MBS pipe. You can also order a fractional T1 FT1 circuit that's delivered on a T1 but doesn't allow the use of all 24 channels. The European version of the T1 is the E1, which operates at 2.048 MBS and uses 32 64 kbps channels, 32 DS0s. It was designed later based on T1s and is a little bigger. You'll find the J1, which is a Japanese version of the T1 and operates at 1.544 Mbps, just like the T1. The T3 connection. A T3 line works similarly to a T1 connection but carries a whopping 44.736 MBS. This is equivalent to 28 T1 circuits and a whopping 672 DSO channels. It uses a signal known as digital signal 3 DS3. That's definitely not the same as DS1, which is generally delivered over fiber optic cable. Many local ISPs have T3 connections to their next tier ISPs. Other entities that often opt for T3 are large multinational companies because they need a capacity to send voice and data between their major regional offices. And don't forget that the reason that MAT doesn't require work out is because of those frame bits. As it goes with the T1, the T3's European counterpart is the E3, which operates at 34.368 Mbps. The Japanese digital hierarchy specifies the J3 circuit, which operates at 32.064 Mbps. Transmission media. Another aspect of WAN technologies that can have a big effect on the speed, bandwidth and volume of data that can be transferred is the type of transmission media. Wireless transmissions use air as transmission media. This not only creates a big challenge concerning security, it also presents us with a signal degradation. The further the signal has to travel from the original source, the weaker it gets. A solution to this last snag comes to us via microwave operators, which transmits signals through the air and bolster them. This approach is a lot more efficient because it can preserve signal strength over much greater distances. The most far-reaching technology uses the air and even empty space to send electromagnetic signals to satellites, from which they are then resent to distant geographic locations. So I'm going to give you here today for this video. If you like listening, please consider like, sharing, subscribing. Thank you.